All right, good morning, everyone. And good morning to Calgary. Uh, Today, we're going to take what you've been doing with databases and take it a step further, not necessarily in terms of SQL skill, but in terms of what we're able to do with it, which means we're going to be connecting your database work with your JavaScript work. If any of you remember the old commercial for Reese's, where two people are walking down the street, one has a jar of peanut butter because that's what you walk down the street with, and the other one's carrying a chocolate bar, and they bump into each other and they have that, you got your chocolate and my peanut butter, you got your peanut butter on my chocolate moment. We're about to do that with SQL and JavaScript. And if you don't remember that commercial, it's really funny to look it up on YouTube. Side note, I'm old. So I've got some code up on the screen, and it's code for something that you've never seen before. But I want to talk through it before we begin. Side note, completely valid code. Yes, it works. But I want to talk through what it's doing, because this sets the stage for everything that we're going to do today. So let's talk through what it does line by line. Let's start with the fact that it is missing a ton of semicolons. There we go. So what's first line do? Requires in a module called PG and gets what from it? Client, yes. That's just ES6 destructuring. And so then second line, unsurprisingly, plain JavaScript. We're creating a new client. And we're specifying the database that we're connecting to. We're saving that in a variable called client. Line 4, what's the client doing? Connecting to the database. It's almost like this reads like English. So then, here's where we have to make a couple intuitive leaps. Line 6. So, client.query. Anyone want to take a stab at what this is probably doing? Querying the database? Yeah. It's a good name for a method. The first parameter there, the string, looks a lot like a SQL query. Select star from users where username equals something. Where things get different is this $1. And that's where the second parameter comes in. Second parameter is an array that just has the string Don in it. Anyone willing to take the huge logical leap as to what's happening here? Bingo, Matt wins a cookie. This is what we call a parameterized query. And the reason I want to start off by showing you this is because this right here is the best practice that solves the single biggest security vulnerability in every website for the past 20 years. Do it this way. There's something called OWASP, which is the Open Web Application Security Program. And this is an independent body that is focused on, unsurprisingly, web application security. And every 4 years, they publish a list of the top 10 security vulnerabilities in websites that they have been studying. And every year, for the past 20 years, what is called SQL injection is number 1. And SQL injection is solved by using parameterized queries. Like, not just how it works most of the time, it's solved. This is a solved problem. And the reason it continues to be an issue, and I'm not being mean when I say this, I'm being honest, is developers are lazy. And the rule basically is you never, ever interpolate data that you got from a user directly into a query. Ever. There is no good reason to do it, and that's why I'm showing you this first. If you build all of your queries in whatever library you happen to be using so that it takes advantage of this pattern that we call a parameterized query, where the $1 is a parameter and we are passing a value into that, you won't have a problem. So if we start off by learning this, we're in a great place. So what PG is going to do is it's going to look at that string Don, and it's going to make sure that there is nothing in there that would cause a problem with SQL. Nothing that would alter the intended effects of the query. Because ultimately what we're getting out of this is we're getting the query select star from users where username equals Don. That's the query we're getting. But let's just imagine for the moment that when I typed in my username, for example, to log into a site or something like that, that instead of typing Don, I typed, yep, that means everything after it turns into a comment. Because if this is what I actually typed in, this exact string right here, oops. If what I actually typed in as my username was that, and I just, as a dev, used like a template string or something like, or string concatenation, and I just stuck that right into my SQL query, I have just guaranteed that I've lost my users table. Whereas what PG does through the use of parameterized queries is it goes through this and it does things like this. And delimits everything so that those just turn into plain text. And Benji, could you turn your computer just like 2 degrees one way or the other? Yeah, otherwise I'm not going to have retinas by the end of lecture. So this is why we parameterize queries. And there is a very famous, it's titled Exploits of a Mom, but it's known as Little Bobby Tables. Yeah. Yeah, this one crops up a lot. About once a year, it makes the rounds on Reddit and Imager and things like that, so that it stays alive. But yeah, Little Bobby Tables is kind of the classic example of why you wouldn't want to allow user input directly into your queries. So if we now go a couple steps further with this code, we have this query. It's being parameterized, meaning the username is being passed in. And then the third parameter is this. What's that? It's callback. Standard node pattern of an error first callback. So the error is first, and the second one is res, which in this case is results. Results of the query. And I'm going to console.log. If I have an error, I will print out the stack trace of the error. Otherwise, I will grab the first row database results that was returned to me, and I will log out the username, because that's going to be the field in there. And then, what do you think client.end does? Closes the database connection. at this point, I could drop the mic and walk away because this is connecting JavaScript to SQL. This is literally just about everything you need to know. Everything else is implementation. Yeah.
What do we expect the res object to look like?
What do we expect the res object to look like? That's an awesome question. So I'm going to suggest that we actually build something so that we can take a look at that. It's almost like I paid him for that, but I didn't. Oh, I'm way cheaper than that. Yeah, if it doesn't rhyme with free, I'm probably not interested. So here's some things that I want to do to approach this challenge. So I have a database of hockey players and teams. It's got 31 teams in it and 888 players. It's the full LHL list from like 2 years ago, like the starting roster. And I just added the Golden Knights because, well, they're a team now. So I've got some data that we can look at. It's even relational data. And this means that we can run some queries and get some information. If we want to take a look at what kind of fields we have available on the players, their name, their team, what position they are, how many games they played, standard kind of stats for hockey players. If you're not into hockey stats, these are hockey stats. If you are into hockey stats, don't get too excited because it's old data. And if we look at teams, it's pretty straightforward. It's just the city and the name. So what we can do is we can now set up being able to connect to this database. So here I'm going to change the name of the database from my app to hockey because that's the name of that database. And this part now hasn't changed from the example that we were just looking at. Is that big enough for you guys in the back? Technology. So let's make a query. Let's do select star from teams. Nice and easy. There's a limited number of rows that we're going to get back there. We don't need a second parameter here because nothing is parameterized. So I can just go directly to my callback function. And Spencer's question was, what does this res object look like? Well, let's take a look at it. So all I have to do is run this, and I get this. By the way, I had taken the liberty of installing the PG npm package already. That's why we're able to just immediately use it. Here's my result object. The command that was used, the actual SQL command, was select, meaning of the possibles of like select, insert, alter table, update, delete, create table, things like that. Select was the one that was used. Row count is 31. The OID is null, which is totally fine. And then there are rows. It is an array of objects. Each object represents a row in the database. And I have 31 rows. And then here, the res object gives me a fields key, which is an array of objects. And each one describes the fields in the database. I get the name of the field, the internal table ID for where it is in memory, which column ID it is. There's a whole bunch of data here about that individual field in the database. There are some functions in here called parse-integer, no-parse, and no-parse that are available as underscore parsers. rows CTOR, rows as array, and get type parser. So that's what's in the res object. Which means 99 times out of 100, I'm just going to need the rows data. But now we can unpack it and see what's in there. And if I want to actually work with that, then what I'm going to do is say res.rows for each. And we know these are teams, because that's what I selected from. And now we can do team.city, team.name, because that formats it as how a team name would actually be shown. And now when I run it, we get that. Though it's just an array of objects that comes back from the database. And this is interesting because it gets us close to a type of library that is very common in application programming called an ORM, which stands for Object Relation Map, or mapper. And the idea behind this type of library is something really powerful, and that is that you should be able to have in your code a one-to-one correlation between a row in a database and an object. So if I run a query and that's going to give me back 10 rows, theoretically I should get back 10 objects that I can actually work with in my code. And that suddenly becomes kind of a cool thing if I can immediately get this data and start writing code against it. And so PG is our first step down this road, and this afternoon when we get to Connects, we're going to be even closer to that kind of ultimate goal, because Connects does some nicer things for us in terms of formatting the queries and streamlining how we get the results. So let's go one step further. So what we can do here is we can also run more complicated queries. So I want to select star from players, join teams on players.teamid equals teams.id. It should. Technically, it doesn't have to, but it makes it really easy to read if you do. Yeah, that's totally convention. There's actually nothing in the spec that requires SQL keywords to be capitalized. It's just a readability thing. So now we've got way more complex data that's going to come back. So let's look at how it's going to, well, let's look at what we're going to get back first. So we are just seeing, let's see. Oh, we're seeing a lot of stuff here. Okay, so we are getting, what's interesting, we're getting something interesting here. So here I have what should be a player. What's wrong with this player's data? It has a team name. So I suddenly have a player named the Oilers. Well, that's not quite right. Yeah, it has. Well, that's totally normal. The ID and the team ID are part of the players table. The team ID is what relates the player to which team they're on. But the other thing that's interesting is this theoretically should be the first player in the database, but it has an ID of 12. And if you notice, as we scroll down, you're going to see that the ID and the team ID are the same for every single one of these players. So this is an interesting quirk of how PG does join queries that I want to show you guys from the beginning, because this will cause you hours of pulling your hair out if you don't realize what's going on. The upside to a library like this that gives us the correlation of a row in a database to an object of code that we can deal with is that we now have code in our that is just objects, and therefore it's easy. The downside is that if we give it a more complex query that joins two tables together, it has to make some assumptions as to what we want back. And this is a very specific case, which is sad because it's a very common query. This is a specific case where PG is dumber than a bag of hammers. Because what it has done is it has created an object for the player that had the ID and the name and everything else. But what's interesting is it then brought in the team data, and where those two shared field names, it overwrote them. So this ID 12 right here is the ID in the database for the Edmonton Oilers. And the name of the team is the Oilers, and now there's this city field down here, which normally wasn't on players. So it's basically merged the two objects like we would do with object.assign in JavaScript. And so we get what looks like bad data. But if we understand what's going on, now it starts to make sense. There is a way to solve this problem. Unfortunately, it takes a little bit of typing. What we have to do in this case is we have to request specific fields from the tables. So player, I want to be able to type players.id, for example, and let's say players.position. We'll do teams.name, teams.city, and that'll be good to start with. And by specifying the fields in the format of table.field, now I will get back what I want. Okay. Yeah, sure, we'll get the player's name too. That'd be good. Good call. We're still not getting it. Oh, one moment. That's my fault. I meant to. This was why I had skipped name. Let's give it an as in the query. Give it an alias. And then it will be named. There we go. So why did I do the as? Because even though I specified that I wanted the player's name, it's still, the key on that is still just name, which gets overwritten by the team data. Yeah, because I can't have a key, the problem there is I can't have a key in my object named players.name. It's because I didn't request the team ID. But because I had players.name and team.name, those overwrote. So by using the as, I gave it a unique name, and now there's no conflict. Nope. It's because of the fact, so the reason it's happening is because both of those tables have a field that's the same name. So if I request both of those fields in one query, I'm always going to get the second one's data. Yeah. And it's the way PG assembles the data when it comes back from the database. So I have to work around that. So this is another very common gotcha, but this is one that's a developer gotcha as opposed to a security gotcha. Calgary, you guys are uncharacteristically quiet today. Everybody okay over there? What was that, Sebastian? Yeah. Okay, so the question is like how and why is it doing what the heck it's doing? So here's what's happening. The query is running and it's going out and fetching the data. The data streams back in from the database. And when the data streams back in, what PG does is it builds an object to collect all that data from each row. And what it's doing is it looks at the first field that comes in and says, oh, this one's named ID. You know, whether it's players.id, teams.id, doesn't matter. This one's named ID. Awesome. I'm going to create a key in my object named ID. I'm going to set it to that value. Fantastic. Next one comes in. It's named name. Awesome. Key is named name. I'm going to set the value for it. Next value comes in. Oh, cool. This one's named ID. Okay, I've got a key named ID. I'm going to set that value to it. It merges, is what it does. Because it's processing in a stream, as the data comes in, it's just going, oh, hey, I've got a key. I'll set that value. So, yeah, it makes sense when you understand what it's doing, but it's dumb. Yeah. Right. Yeah, it's just reassigning the value to the object. Yeah. Because it's just in a loop going, well, here, what's the field name? The field name is ID. Great. Make an ID key and set the value to it. And JavaScript, of course, being JavaScript, is going to go, oh, well, I've already got a key named that, so I'll just set the value to the new value. Yeah. It's not JavaScript's fault. It's a little bit of PG's fault. But once you understand the mechanic of what's going on underneath, it makes sense. It's still dumb, though. What the as does is it changes the field name that's coming in. Because now okay, let's take one step back and this will help. Understand that the whole purpose of SQL, a SQL query, like a select query, is to build a new table of results. Yeah, that's all select does. There's tables of data over here, and you want your custom table of results. That's what select does. So you, as the developer using the SQL query language, can specify what those column names are called using as. So those column names become the field names for each one of those rows that's coming back. So using as, I can now give that field name a unique name that isn't going to get overwritten. Right. Yeah, exactly. Because when SQL reports it, it reports it as players.id and teams.id, so they're unique column names, and there's no overlap. But JavaScript can't set a key with a dot in it. Yeah. So it's not really JavaScript's fault. It is totally PG's fault for not handling this well. So this is the other gotcha that I wanted to show off with PG from the beginning, because this one, honestly, I did this for the mentor's sake, because this will, there will be a lot of time spent with mentors if I don't show that this happens. And different libraries are going to handle it in different ways. Some of them are going to handle it better, some of them not at all. So this is a case where we have to handle it differently if we want this to work the way we want. And I can do that just by using an as. I modify my query, and then I get a different object back. Because when I was talking about the ORM and how it maps a row in a database to an object, ultimately what I'm saying is that ORM maps a row in my selected results table that I get back from SQL. It maps a row of that to an object, which is quite nice, because if I'm only selecting specific fields, I only get an object of a specific size. It only has the data in it that I want. Select star is great, but that's like using a fire hose to fill up a teacup most of the time. It's normally way more data than you ever need. And so as you get better at SQL, one of the cool things that you have the opportunity to do is build more efficient queries. Less is actually more in this case, because the less data you're pulling, the faster your queries run, which is kind of a neat fact. So now that we're at this point where we have, where we understand what's going on here, now we can start to look at how we can improve the pattern of this code that we're using. And so one of the first things I would do is that, because that's a lot easier to read. And then the second thing I would do is that, because that's a lot easier to read. And so now I'm starting to split this up, refactor it a bit, make it more readable, more maintainable. Because now I start to be in a situation where I could build myself I'm not. In Narnia, the mythical land on the other side of the armoire, that's where the error is getting handled. Handled. Yeah, so now we have error handling. Yeah, I can ship this now. Now I can start to build something like this. No, I don't want to do that. And now I have a function that will allow me to just run a query. And I can even do things like provide, just a default value, so that whether I'm running a parameterized query or not, it will always have values. And so now I'm starting to build my own module for doing this, which gets cool because now it starts to give me flexibility to do more things, and I don't have to rewrite my code every single time I want to do something. So I can now, set up, for example, maybe I don't want to do this one. Maybe I want to do select city from teams. Let's just say that's all I wanted. Well, now I can run query handler. And when I do that, I get back an array of objects that are just cities. And if I decide that I don't like the way that query handler is working, this isn't much better, but you know, I could actually decide that I'm going to write a custom one. There we go. And we get nice clean data at that point. I might notice, for example, that my, because Las Vegas was added at the end, it's no longer alphabetized, whereas all the other cities were alphabetized. So I can fix that. So I would write a custom query handler here. I just sort it. Well, in this case, it's a.city. Oh, womp womp. There we go. Now it's sorted. And there's Unix being as dumb as it always is. Yep. Anyone know why that happened? There's actually kind of a funny reason. Yeah, it has something to do with the space. See if I can get away with it that way. Yes and no. Things get kind of funky. Yep. So the other way to solve this is that. Basically extract the city from all the objects so that you just get an array of city names as strings, sort that using the default alphabetical sort, and then iterate through it. And then this, theoretically, will do that, which is exactly what we wanted. That should return the city. No, it's just city. Oh, haha. And ta-da. So none of that really was database. That was all JavaScript. But the point is, once I know that I have an array of objects, I just get to practice all the skills that you've been doing for the past 3.5 weeks. This part, that's the magic. It runs the query you give it and then gives you back data. You know how to run something and have data passed to a callback. So this pattern now isn't magical. The hard part will be, because SQL's new to you, writing good SQL queries. But even if you don't write good queries and you write queries that give you too much data or the wrong data, you now know how to see the data so you can decide whether or not you wrote the right query or not. And if you want to practice your queries, you go into pSQL. Because if it doesn't work in pSQL, it's not going to work here. Guaranteed. So, chew on that in your brains, take a break. We'll come back in 10 minutes. Yeah.
I'm not crazy. It was writing over it.
Okay.
But only in pSQL.
Okay. pSQL does not use a proper terminal driver. Okay, so when we last left off, we had gotten to the point that we could define a string that had a query in it. We could define a function that was going to handle the results of that query. We could run the query and do stuff with it. So let's actually make, now that we have reached this point of fluency, let's actually make something that works real. However, before I go on, Mackenzie had a question about why did ID not get overwritten. Did I answer that when I explained how PG reads in the data? I want to make sure I answer that question. So. Cool. Okay. He says all good. So, moving on. So what we're going to do now is I want to be able to not have my phone ring during lecture. I want to write a command line script here that is going to allow me to search for a player and I'm going, if I find a single player, I'm going to output everything I know about that player. So I'll output their stats, I'll output what team they're on. So that's scenario number one. Scenario number two is that I don't find any players, and I need to output nobody was found. Scenario number three is that I find multiple players that match. And so then I should be able to prompt, I should be able to say, hey, did you mean Bob or Sam or Sally or whoever? So that way we can take the quality of the data that we go back from the database and make an informed choice about it. So, so the first thing I'm going to do is I'm going to start off and I'm going to start modularizing my code from the beginning. I'm going to connect to my database. I'm going to export that, and then I can import it into my main script as an object that already has a database connection on it, which will be nice. We'll call this playersearch.js. And I'm just going to import this as DB because that's representative of what it is and it's easier to type than client. So the other thing I need is I need to be able to grab whatever was typed on the command line. In this case, I'm going to call it just search, or let's call it search data. Process.argv slice2 join. I'll just take everything from the second argument onwards and turn it into a single string. That way I can have a name that I search for, like Austin Matthews or Henrik Sedin or something like that. Because otherwise it would, it's going to split it up as an array, and so I would actually have separate pieces of that as an array. So I'm going to go ahead and just turn it into a single string. So now I have my search data. So now what I want to be able to do is well, actually, let's write this as a nice thing. So select. I'm going to have to figure out what fields I want, but we know that the player name we need to deal with. And let's start off. Let's double check what data we have access to. So I've got name, position, goals, assists, points. That's enough to start off with. Goals, assists, and points. I don't want to type all that other stuff out. You guys know that I can type. You don't need to watch me type all that. Players.goals, players.assists, players.points. I also want to know what team they're playing for. So teams.name. And I'm going to go ahead and give this one a different name as well, just so it will be easy for me to differentiate. Teams.city. I also want players.position. I want to know what position they play. That will look good when I output it. So that's what I'm going to select from players. Join teams on players.teamid equals teams.id, where players.name equals $1, because that's going to be the parameter that I'm going to pass into this query. And now I can do db.query, my actual SQL query. The data, the values that you're passing in to parameterize always have to go in as an array, because you can have from $1 to $0. So you can pass in up to 10 parameters. And they will be in order in the array. Interestingly, $1 is the first one and $0 is the last one. Just to mess with you, just to keep things, interesting. And then I'm going to have my handler function that's going to deal with that, and I'm going to define that right now. So, first off, for Olivia, we will handle the errors. Just in case. You are the weakest link. Goodbye. So, now we're going to need to consider our 3 scenarios. So if we think back to what we did before the break, and we think back very early on when we looked at the res object, what is an easy way for us to tell if we got data back? There are 2 answers to this question. Both of them are correct. There are also many incorrect answers, like strawberry, for example, is an incorrect answer. But what are some of the correct answers for how I can tell that I did not get any data back in my query?
Does res have a field to be designed to tell you that?
It does. Row count. Matt gets another cookie. If row count is 0, I didn't get any data. Also, if rows.length equals 0, which is how it sets row count. So, if res.rowCount, actually I'm just going to do it this way, because I technically have 2 scenarios. Either I got data or I didn't. And if I got data, I then have 2 cases in there. Console.log, we didn't find anything. Please try again. So that'll work. Always close your database connections, boys and girls. So then if we have a row count, we want to check and see if it's greater than 1. Because if it is, we're going to handle it differently. So if res.rowCount is greater than 1, we're going to say found multiple players. Please pick a name and try again. And then res.rows.forEach player. All I need to do here is show the player's name, really. So that will show all the players that I found, because I could theoretically, in fact, let's really make this smart. We'll use a light query. So we'll actually do kind of like a search, because I could theoretically pass in like, node player search.js space A, and I would get all the players whose name had an A in it. Well, sort of. I suppose I need to do yeah, I'm going to have to do some percent signs. So let's do this. There we go. That should work. Whatever I type in, it will, yeah. Basically, as long as that string exists somewhere in the player name, it will return it. I will also piggyback on the performance conversation that Carl had with you yesterday and say that this is slow. Like, we won't see a huge performance hit with only 888 players, but if, let's imagine just for the moment that we were doing this on like Pinterest's database. We'd be here for a week. And they have big servers. So I've written a bunch of code so far. I'm just going to let's do this. We'll actually put how many players we found in there. And for now, I'll just put that so we can come back and fix that in a minute. So let's see so far how much of this is actually working code. So we'll get out of this. And node, player search, and hold on. Do you have a preference for who I should search for? Let's try something like this. Got nothing back. Awesome, fantastic, stupendous. Could not ask for better results. Let's try just this. Still get nothing back. Nothing and nothing. Well, on the bright side, there are no errors, so it works, right? Oh, sorry, that's the... no, I'll be nice to that product. There is a rather famous operating system made by a company who has a certain name that starts with M. that there are many things that their operating system does where you do it and it gives you absolutely no response, but when you contact them about it, they're like, oh yeah, it's not a bug. Well, it didn't do anything. Yeah, but it didn't throw an error. I worked for them for 4.5 years. I can get away with saying this. So we don't need this open anymore. So let's actually trace through what's happening here. Let me stare at it first to see if there's anything obvious. Okay, so let's start off and just make sure that this is what we want. Yes, it is. Fantastic. And now let's make sure that this is doing something. And it's not. Found the problem. So the function's not getting called. So the great question is, why? Well, the function's defined, and I pass it right here. And my query's there, and this is db.query. Let's just test something. Parentheses. Well, if you... He says parenthesis. Where? On handler. Oh no, I don't want to run the function. I definitely do not want to run the function here because I'm passing it as a callback. You never run the function when you're passing it as a callback. What's interesting is that my database isn't querying at all because I did this one here, and that should log out 31, and it did nothing. So the problem is the database isn't querying. So it's something over here. So I'm going to test. Would db.end execute before the callback finishes? Oh, yes, it probably would. You are a smart person. Congratulations. Welcome to the wonderful world of asynchronous programming. Let's try that. Oh, look. Calgary, Cheng, you get a cookie. In fact, you get 2 cookies. I can't believe I did that. Much shame. So, let's go back to where we were. Yeah, the database was closing the connection before the results were coming back. So it was just like, okay, I'm done. I moved db.end inside the callback function. Yep. Yep. Well, that's not just JavaScript. That's any asynchronous program. Yeah, any asynchronous programming. Yeah, so good. We found 1 player. Fix this. If we do something like this, found 2 players. Pick a name and try it again. And so now, theoretically, if we were to... All right, that looks like it's doing what we want it to do now. And if we do something ridiculous like this, it actually searches. Found 636 players that have an E in their name, which means there's 252 of them that don't have an E in their name. Fun fact. Share it with your friends and family. Oh, you mean like if I try and, you know... Well, I know I've got a spare table in there called... Yep. Basically, it dropped me into it dropped me into a REPL for some reason. That was interesting, or it just gave me bad output. But it yeah, I know, but that doesn't necessarily mean that anything bad happened. Potentially. Nope, table's still there. So, yeah, that's interesting. I haven't seen that happen before. But it didn't do anything bad. Yeah. Yeah, this is also the kind of behavior that you would catch in development and go, maybe I shouldn't push that to production. Yeah. Does it print the players in ID order? Yes, it would. It would do that. Yeah. And we can actually double check that. Yeah, he's number 2. So. How are they arranged? However, it got read in from the CSV I found. I grabbed it from NHL's stat site. Yeah. NHL actually at the beginning of each hockey season puts out a CSV with all the, basically all the data in it. Or I don't know if it's, sorry, at the end of each season from the previous seasons. So I need to grab last season's data so that this is updated. But yeah, you can just read the CSV in and it's whatever order they put it in. But in this case, it's probably, because the default on NHL is to sort by points. So in this case, he would have been number 2 in points. Yeah. It's like, oh, I want that for my hockey pool. Yeah, no kidding. Okay, so now that we know that that works and does what we want it to do, let's fix our last condition here, which is we found one player, we want to display them. Player.playerName, console.log. Let's do something nice for ourselves, and let's make a function that will actually expand the player's position, because it just has like L, G, R, C, D for what position they are. So we'll fix that. And goals, player.goals, assists, player.assists, and points, player.points, and last but not least, team, player.city, player, oh, I don't need to interpolate that, player.city and player.team name. So it would, oh, that makes a lot more sense now. In my head, I had set a variable for player. This is just me defining what my output is going to look like. I'm going to very quickly check and make sure that I did get the team city in there. So now I just need to write the function easiest way for me to do this is right wing, C would be center, D would be defense, and G would be goalie. And returns, positions, pause. Perfect case for using bracket notation on an object, because I don't know what's going to be passed in, and I just want to grab whatever key that is. Okay. I have not used jQuery anywhere. Is template strings. So why did I use template literal on some of them? Because I wanted all of these to be on one line. So I just use template literals because that's the easiest way to interpolate, because otherwise I'm using plus signs to concatenate, and that's ugly. Whereas these, each one is on its own line, so I can just pass it as parameters to console.log. I mean, I could have used template literals for the other ones, but console.log is going to space it out for me anyway. In this case, I needed to define all of that on one line, and that's going to be parenthesis. These are curly braces. And jQuery is also only on the front end. Yeah, jQuery only exists in a browser. Could not possibly work in a million years. Yes.
I knew that.
Okay. Yeah. I'm affirming. I'm confirming your knowledge. Yes. Cool. So now, node player search. Vulkan. There we go. And if we do something like, I don't know, Z. 25 players. Now, I wonder, yep, it's case sensitive. So there's 35 players who have a lowercase z in their name, and 25 players who have an uppercase z in their name. So there you go. And let's pick some random guy. And there we go. Big 25-point season there. As a center. Wow. Somebody's going to the minors. Too soon? Okay. Fair. Yeah, but as a center? Really? So yeah, now this is a more of a real world use case for how we would build a tool around connecting our database to our JavaScript code, running a query, getting back an array of objects that we can actually work with in code, and then just spitting stuff out the way we wanted it. If I was going to take this further, this is when I would start breaking things out into modules. I would definitely take all of this. This would become its own function. In fact, I'm going to do that now because it makes me want to puke the way it looks. function, display player. There we go, that's better. Yeah, that's a little bit nicer. But I'd probably take things like these two functions at the minimum and put them in their own module so that you know, they weren't sitting here in the main file, and then I could reuse these in other places if I was building this big, elaborate, you know, app where theoretically I would need to expand positions or display players in several places. Yeah, ultimately, I wrote my query, made sure it was parameterized, ran the query, and then handled an array of data that I got back. The handling is just JavaScript. The SQL cannot possibly be confusing at that point because the SQL has already run. One of the things that I do see a lot of people new to this kind of code that will get frustrated with is they're trying to fix their SQL query in their handler. And the code's already run. The query's already run at that point. This is just JavaScript in the handler. If you don't have the data you need to go back and fix the query, but that's not something that you fix inside the callback function. So build your query first, test it in pSQL to make sure that it works, then run the query method on it and handle the results that you get back. And remember, you can always just log out res.rows or res.row count and see how much data you got back. Cool. No, the callback function has nothing to do with the SQL whatsoever. The callback function is what takes the data that SQL is giving you back and lets you work with that data in JavaScript. SQL is what's generating the new table. That is all done for you before the data ever gets to the callback function. Yes, anything that has to do with pulling data out of SQL and formatting it in some way so that you can work with it in JavaScript, that's all SQL. That's all your queries. Yeah. And what's interesting, and I'll go ahead and tell you this in case you haven't intuited it already, but if I look at how the order of the parameters, that's the order of my troubleshooting. I'm going to make sure my query is right. I'm going to make sure I'm passing the right data to it. And then as long as those two things are correct, then I will go and troubleshoot my callback function. Because until those first two things are correct, it does not matter what I have done in my callback function. So the data has to be correct. This goes back to that LSD acronym. Your logic, your syntax, your data. If your data isn't correct, all the logic in the world will not help you. Cool. Calgary, how you guys doing? Anybody have any questions here? Okay, you guys are good. Waiting for a response from Calgary. Okay, Calgary says they're good. I'll package all this code up, send it out. I'm also going to send you, I'll send you little Bobby tables, but I'm going to send you the link to the PG documentation just so that you have it handy and already pulled up. So, cool. Thanks, folks.